Okay, so here's a demo of running the PS3 Linux kernel and system on PS3 with firmware version 3.41. For those who haven't been following, I have been working on a project which uses the exploit that was pioneered by the PS3 jailbreak device to essentially run Linux, except instead of as other OS, I'm not trying to boot other OS on the PS3. I'm actually using Linux as game OS. So since other OS and game OS are really just two different modes on the PS3. You can basically just run Linux as game OS, and the interface to the hypervisor is the same, and it pretty much just works. The trick is to use the exploit to take control over game OS and actually wipe it out, replace it with Linux dynamically. So I use the exploit and then stomp over game OS, stop all game OS activity, and replace and load Linux on top of it. Now, just to prove my point, here's my PS3. It's hooked up to this monitor here. I'm going to just turn it on normally, unplug anything weird from it, and just to show that this is firmware version 3.41. This keyboard here, which is ironically a PS2 keyboard, is hooked up to the PS3, and it's booting up. And let's log in. Let's go to system settings. And system info. So this is from version 3.41, right? And now you know my MAC address, who cares? Okay, so I'm going to turn off the PS3. And since this is going to happen pretty quickly, I'm going to tell you about it first. So I have two windows here. This is the console, and this window here is just a simple terminal that's showing debug messages that are broadcast by the PS3 onto the network. So I'm using the Ethernet port as a debugging mechanism, both for asbestos, which is the name of my Linux bootloader, and Linux itself. So that's just going to show the messages coming from the PS3 through the Ethernet port. This window here is actually a window, a terminal into my exploit device. The firmware version 3.41 exploit is based, as you may know, on USB devices, so you need some kind of programmable USB device to implement it. I am using this iJet V2 board, which is a board with a TI OMAP3 processor. It's the same processor that's used on the Palm Pre, the Nokia N900, and the Motorola Droid, and the Open Pandora console, and a few other devices. But you could use any other device that has been used to implement this exploit or could potentially be used. So there's already a port of this bootloader to the iPod, I believe the classic ones, and you could also there's also a port for the Arduino, and there should be a port coming up soonish for USB AVR devices. The Arduino port is for software USB, not hardware. So you could use a TNZ or a USB. This is an AVR stick. You need at least 64 kilobytes of memory, but you could load this bootloader from an external memory. So there's a port for the Arduino Mega, and then there's a port for some older Arduino with less memory that actually uses an external EEPROM memory to store the bulk of the code. So if you have a USB device like I do here, well, you can run it. The nice thing about this one is that it has an Ethernet port, so I can just log into it and see everything happening in real time. So this window here is just an SSH connection into that board, which runs Linux, and it's running the exploit code, which is a reference implementation that I wrote. But this part could be replaced with any other implementation. It doesn't really matter. So what you do is you turn on the PS3 with the power and eject combination, and that starts game OS. It starts loading, and it triggers the exploit. The exploit initially just works like all the other exploits, but instead of leaving a patch into game OS, what it does is it completely replaces it. It uses game OS USB services to load a second stage. So stage 1 triggers directly through the exploit. It uses game OS to load stage 2, and stage 2 then starts the process of booting Linux and takes over game OS. Now what's going to happen is this is going to load the USB exploit, run stage 1, you're going to see all the messages here. Stage 1 is going to show a few quick messages at the end saying it's loading stage 2. Once stage 2 loads, stage 2 uses Ethernet debugging. At this point, there's no USB stack because game OS has been destroyed effectively. It's no longer in memory. So USB activity ceases and it switches over to Ethernet. It's going to show some debug messages, then bring up the network, and by that I mean actual IP. It uses debugging before bringing up the IP network. So it's going to use a DHCP server to query for an IP address and a server, and then it's going to use the TFTP protocol to load a Linux kernel image from that server, which is this computer, of course. So you're going to see it load the Linux kernel, and then it's going to jump into it. The Linux kernel itself is patched to also debug through Ethernet in the same way, so it's going to keep scrolling kernel messages here really quickly. It's almost instant. And then it's going to bring up the network, and once it does that, you won't see anything else, because once Linux brings up the network, the debugging driver for the Ethernet just shuts down. So Linux is set up to boot with an NFS root file system, which means the Linux root file system is actually held on this computer and is being streamed in real time through Ethernet to the PS3. So Linux is going to do that behind the scenes. You won't see anything yet because the frame buffer driver has a small glitch that means it will not work for the first few seconds of Linux boot. So Linux will stop showing debug messages. It'll start running the user space file system. It'll start booting up Gen 2 Linux image, which is what I have loaded into my computer. Once that happens, and in a few seconds, you will actually see the frame buffer driver initialize on this monitor, and it'll finish booting up. So let's give it a try. It's plugging the exploit device to the PS3. Turn it on with the, well, you need to flip the back power switch first. Turn it on with the combination. And wait a few seconds. So, first, the exploit. Let's show in a few seconds here. Here it goes. At stage 1, at stage 2, it's loading the kernel. That's the kernel. And now nothingness for a few seconds while the frame buffer driver gets its act together, but it is booting Gen 2 right now in the background, and there we go. That's a Gen 2 Linux boot process. You saw you may have catched the 7 SPs at the top there, not 6 as is usual. It's actually 7 when running under Game OS, so you get an extra SP, and once that finishes, almost there we go. Let's see if I can log in a little bit. PS3. Oh wait, no, I'm an idiot. Username root, password PS3, and there we go. So just scat proc CPU info, and there you have it. The 2-threaded cell broadband engine processor. And I have just the basics here. It does networking. It does I have all the SP tools and toolchain installed. So it's basically a PS3 Linux installed, just that it's running through netbooting from this computer. And it even halts. You can even turn the power off, and it actually shuts down Linux. So at this stage, this is I think this is useful enough that other people might be interested. I've been tweeting about it, and but I'll post some information about it on my blog soon, so that other people can try it. You only really need asbestos, a compatible device, or you can port it to your own device. It's really easy. If you have a device that has 64K of internal or external memory and can run PS Groove or some other PS3 payload, you can just replace the payload and add a few instructions to implement the stage 2 thing, which is really, really trivial, and run asbestos. And for Linux kernel, you can use a vanilla PS3 Linux kernel. You do not need any special patches unless you want this debug terminal thing. I have a few patches for that on my Git repository if you want them. And as for asbestos itself, it's on my server, and you can just download and build it with that even comes with a toolchain script that you can use to make a PS3 toolchain. So I'll go post that in a short while, and see you next time, maybe with, I don't know, proper graphics or something. We're still trying to figure out how 3D works, but 3D should be available. I mean, this is essentially Game OS, so of course it has 3D support. We just need to figure out how to use it. So, see you in a while.